basically autonomous robot combat system. Basically, this robot is developed for the vision-based attack and aviation strategies for military purposes. And in this complete robot is developed in C++, avoid C++ Visual Studio platform, which provide us the camera feed 15 to 30 frames per second FPCS and it is the opponent robots avoid obstacles. It track the opponent robot, avoid obstacles, execute laser attacks while ensuring collision-free navigation. The project is divided basically in two tasks. One is attack and second one is evasion, like in defense path. Okay, so it also this robot will have object detection, path planning for obstacle avoidance, decision making algorithm to optimize combat strategies. So in this complete section, we have just developed the complete real-time image processing, path planning, obstacle avoidance. Path planning basically used for obstacle avoidance. And third one is decision making algorithm to optimize attack and evasion strategies. So this is the overview for this robot. Like vision sensors used in this robot, like infrared camera, event-based camera, lidar sensor, RGB camera, and stereo vision system, and monocular camera. Okay, so these complete cameras used to detect and to avoid the obstacle avoidance, path planning using different defensive mode and attack mode as well. Okay, so this is the problem statement for this robot, and in which I have completely described like how it will do in human intervention, how it will do through attack and collision mode, obstacle avoidance, boundary walls, and results in penalties as well. So this is a system architecture for this complete report. This is contains the array of sensors. It also having, and this is the obstacle avoidance sensor, actuator basically motors used, and processing controller like which is microcontroller and Wi-Fi module system and the power supply. Basically, Wi-Fi module system is used to communicate the complete communication through in between the sensors as well as to the users interaction as well. So I have also added all the like motor control module translate high level decision into movement commands, and finite state machine also used to behavior of the robot to control the behavior of the robot, transition between attack and evasion system. And this is the design methodology which also in which I have added the image processing, robot tracking system, path planning, and this is the employed robot final product will be like this. Okay, so for the path planning it will use the repulsive forces and the target exert and attractive forces. And next one is for image processing, real-time image processing. It will use the live video frames and applied pre-processing techniques to enhance object detection, grayscale conversion, and everything. And in the second phase, path planning and navigation, which also used for robot calculation, the shortest collision-free path to the opponent using a potential field algorithm. In the task 2, basically evasion, like which is defensive mode from the opponent robot. So it will use the dynamically reposition itself behind the nearest obstacle and continuously updating its path through opponent's movement. So finite state machine also use, and third phase is basically decision making and combat strategies when the high level of combat behaviors of the robot And in attack mode, robot align its laser by computing the angle between its current position and its next move. And final phase is basically performance and optimization and validation. It also having this robot basically tracking accuracy and evasion success rate is 90% hit rate against stationary opponents and 85% evasion success in obstacle rich environments. Okay, so it's having a 70% win rate in simulated combat rounds. So I have just added its the simulation in the Visual Studio C++ code, which is having 85% test cases and 75% against moving targets. Okay, so these are two robots used in this section. And the next one is, yes, this is a robot movement with adding of obstacles to avoid the obstacles and path planning. So this robot is a final prototype of the robot which is having for which is testing in robotics lab, and which also contains the static opponents, obstacle positioning, computational latency, and 70% win rate in head-to-head combat rounds. Okay, so this is the conclusion I have added in your project, and this is the references. So let me just show you, these are the outputs I have just developed. These are the program code for the complete robot, which is developed for the its threshold, its width, its length, its height, its camera settings, its complete object detection, deactivation of the program, activation of the program, through image processing, through different camera, and as well as different sensors, movement of sensors. So see, I have added the complete its prototype, its simulation of C++, its path planning, its complete components and architecture as well. So these are the complete code used in our section, like timer section, which timer used in it, and VN section, which VN is used in this section, and the image transfer as well. Okay, see the image transfer from one robot to another robot and through Wi-Fi section as well. This is the complete code for program. Okay, so this is the complete section to represent the robot, its vision, and its image section, like examples of image dynamic environment, what environment will be used in the multi opponent. In the, for example, these are the different steps I have used to calculate the like obstacles, like path planning and everything. Okay, so all the files included in this section, so you can just check and see the output results accordingly. Okay, I have also added this MATLAB C++ code as well. So I think this is a complete. Okay, if you need to ask anything, you can ask me and contact the WiredWhite platform. Okay, thank you.